and welcome to our video on the lock and key model and the induced fit model for the mechanisms of enzyme action. We're going to be comparing these two models and looking at the differences between them. And I'll start off by saying that the lock and key model is no longer used and the induced fit is accepted now, so this is what we use now, because this model is quite simpler. So what happens with the lock and key is it's like a perfect fit, so the substrate is complementary to the active site, and this is the active site here, and so the substrate will bind to the active site and there will be some temporary hydrogen bonds formed, and this will form an enzyme substrate complex. And then the substrate will be broken down into smaller products, and because those products will no longer be complementary to the shape of the active site, they will be released. And that is pretty much all it is. So once it's binded and you've got the substrate being broken down, then you're going to have the enzyme product complex. That's when it's not complementary and they're just going to be released. But what the induced fit model suggested was that actually the substrate, it's still complementary, so don't forget it is still complementary, but it's not an exact fit, so it's not perfect. There's some slight differences. So when the substrate binds to the active site, there's going to be non-covalent forces, so ionic hydrogen bonds, etc. And because what's going to happen is the R groups of the amino acid are going to change and give a more precise fit. So the R groups change shape. So then it's going to fit more precisely, and remember then we're going to have an enzyme substrate complex formed. And then once we've been broken down again, the products aren't going to be a complementary shape to the active site, so they're going to be released. So products are going to be released after the enzyme product complex has been formed. The products are going to be released, and then after this the active site or the enzyme is going to return to its original shape. So it's returning to the original shape so that it can then go on and catalyse further reactions. And that is all you need to know for these two models. Thank you for watching.